In this video, we are going to continue using limit rules to evaluate limits algebraically, but from a graph. So algebraically, but also graphically, because we're going to be using those algebraic properties. So let's take a look here. So given the following graphs, f of x and g of x, find the limit as x approaches -6 of f of x times g of x, okay? So remember that the property that we learned in the last video was that we can do the limit of each of these separately, okay? So we've got this f of x in here, and we've got g of x. So we're going to do each limit separately and then multiply that. So we're going to do the limit as x approaches -6 of f of x. And then we're going to multiply that with the limit as x approaches -6 of g of x. So we'll just get to do each of them separately. So take a look. Here's the graph of f. Here's the graph of g. So when we do the limit as x approaches -6 on f of x, okay, so let me get this so that I can draw a line here at x equals -6. So what is the limit as x approaches, x approaches -6 on this function? Okay, it's -3. So -3 here times the limit as x approaches -6 on the g function, okay? And remember, limit needs to be the same on both sides, and this one is not. So the left-hand limit is 0, the right-hand limit is -2. So this one is undefined, which means that this whole thing is undefined. Okay, you can't have one part that's undefined and then an overall answer. 3 times undefined is undefined. Okay, so the answer to this whole limit right here is undefined. So given the graph of f of x below, find the value of the limit as x approaches -1 of f of x squared. Okay, so again, we've got this f of x inside this function. So we can actually do the limit as x approaches -1 of f of x and then square that. Okay, so we'll do the limit of f of x as x approaches -1. Okay, and as x approaches -1, this limit is 2. Okay, so we're getting 2 for that, for this whole thing, right? And then we just need to square that, so we end up with 4. Given the two functions below, find the value of the limit as x approaches -1 of f of x divided by g of x. Okay, so instead of having to be able to divide f and g by each other, we can just do the limit of each and then divide the limit. Okay, so the limit as x approaches -1 of f of x divided by the limit as x approaches -1 of g of x. So the limit on the f function as x approaches -1 is 1. Even though there's a hole, both sides go towards a height of 1. So the limit as x approaches -1 of f of x is 1. And then the limit as x approaches -1 of g of x is -1. So then 1 divided by -1 simplifies to -1 as our overall limit. All right, this one we didn't really talk about in the properties, okay? But so if you have a limit of f and then in parentheses you have the x plus 1, this is just a polynomial in here. So you can just take and still put that in, okay? So what you're really doing is the limit of f of 7, okay? So you're looking at f of 7 instead of f of 6. Okay, so we're as x approaches 6 plus 1 instead of just 6. Okay, so we're going to look at 6 plus 1 here, which is 7. Okay, and the limit of that is undefined. Okay, so when you've got this x plus 1 inside the function, as opposed to if it looked like this, the limit as x approaches 6 of just f of x, then we would have looked at 6. But we're doing it of f of x plus 1. So if I did f of x plus 3, okay, so if I was doing f of x plus 3, then I would be looking at 9 in this case. Okay, which would be 6. Okay, so if you have something added or subtracted in that function, let me get this one on there too, the limit as x approaches 6 of just f of x, then we would be looking at the actual 6. Okay, this one is doing limits of composition. So this one's a little bit different because we're going to need to do the limit of the inner function and then use that in the f function. Okay, so we've got the f function on the outside, and then on the inside we're going to do the limit as x approaches -5 of g of x. Okay, and so we'll evaluate this limit of g of x and then actually plug that number into f instead of doing the limit again. So we're going to go to the g function, which is right here, and we're going to put in, going to do the limit of -5. Let me change the color of that to match. So we're going to do as x approaches -5 here, which the limit is 4 on either side of that. The height is 4. So we have this f function and then this whole inner part, the limit as x approaches -5 of g of x was 4. So now we're actually going to just plug this into the f function. So we're going to go over to the f function, look at 4, plug it in, and what do we get back? 4. So that whole thing right there, the limit as x approaches -5 of f of g of x is equal to 4.